Hi everyone. As we're starting to get ready for our Chapter 2 test, I thought it might be helpful to put together a quick little review video that goes through all of the types of problems that could show up on the Chapter 2 test. So that way as you're studying over this upcoming weekend, if you get stuck on a problem, you'll have a resource to go back to. So what I'm going to do is I'm going to go through the Chapter 2 review that Mrs. Jennis put together. It has a lot of practice problems, so it's going to be a really good resource to get you ready. And what I'm going to do is just go through two of each type of problem, again, just to give you something to go back to if you get stuck on these problems when you're studying on your own. So the first thing we're going to do is go back all the way to section 2.5, and this is where we are simplifying expressions involving products of negative factors. So they looked like this, where we had a whole bunch of factors multiplied together. Some were negative and some were positive, and we knew we had to simplify those. And if you think back, simplifying, we said, meant no parentheses, right? That was our big rule. No parentheses. And we also said we didn't want to see all these negative signs, and in some case we didn't want multiple variables. We needed a way to make that look much more simple. So Mrs. Jennis has the steps here, and I'll talk through them as I do a couple of problems. So let's look at number 1. So number 1, I have the product of -4 and -x. So my first step is to count the number of negative factors. In this case, I have 2 negatives, which is even, which I know means my answer is going to be positive. Another way we can think of it, right, we said anytime we have 2 negatives, those can be grouped together to make a positive. So either way, now I know my answer is going to be positive. My next step is to multiply any numbers that I see. In this case, my only number is 4. So I'm just going to copy down my 4. And then lastly, it says count the number of variables to determine the exponent. So in this case, I only have one x. So I really have x to the first power, but I'm not going to write that exponent of 1. So this would be my simplified expression. My parentheses are gone, my negatives are gone, and I just have one variable. Okay, I'm going to jump down to, let's actually do number 4 next. So number 4, again, my same process. The first thing I'm going to do is count the number of negative factors. Here I only have one, which is an odd number. So I know my answer is going to be negative. So I'm going to put that here. Step 2, I'm going to multiply any numbers. Well, in this case, I actually have a 4 and I have a 2. If I multiply 4 times 2, I get 8. So 8 is going to be my new coefficient. And then I'm going to count the number of variables. So I see I have an x here and an x here. So that tells me I'm going to have x to the second power. So that's how we would simplify these expressions. Okay, I'm going to go to the next page. It's the same idea, except now we're going to use these simplified expressions to evaluate an expression for a given value of the variable. So my first step starts out just the same. To simplify, I'm going to count the number of negative factors. In this case, I have 2, so those will become positive, and my answer will be positive. Next, I'm going to multiply. Let me focus this a bit better. I don't know that that helped. I'm going to multiply the numbers in my expression. So I have a 2 times 4, which is 8. And then I'm going to count the number of variables here. I just have 1d, so it's going to be d to the first power. Now, something very important here. The next step asks me to evaluate when d equals 2. It's really important now. We know when we evaluate, we're going to substitute 2 for the place of d. It's really important that you substitute this into your simplified expression and not the original. So to do this, I'm going to take my simplified expression. Instead of d, I'm going to put 2, and that's in parentheses because I know I'm multiplying. And then if I simplify 8 times 2, I know my answer is 16. So those are our problems from section 2.5. Next, we're going to look at our section 2.8 problems. And I have this stapled, so I'm going to unstaple that here. So now we're looking at 2.8, and we've moved on. In 2.5, it was all about multiplication and products of factors. Now we're going to look at quotients, right? So when we think quotient, we're thinking division. And our first target was to simplify a quotient by multiplying by the reciprocal. So just as a quick review, to find the reciprocal, all we're doing is flipping the numerator and the denominator. So for number 1, if my fraction is 5/7, I know my reciprocal is 7/5. And notice I don't put an equal sign because these two fractions are not the same, but they are reciprocals of one another. And so then we used this skill of finding the reciprocal to be able actually to find a quotient. Instead of dividing by a fraction, we said that was the same as multiplying by the reciprocal. So if I rewrite this for a second, what this problem is really saying is 8 divided by 1/6. And dividing by a fraction is pretty hard to kind of be able to visualize, so what we said is, I can actually change this to make it a much simpler problem. I still take my 8, but our division now becomes multiplication, and I multiply by the reciprocal. So the reciprocal of 1/6 is 6/1, or just 6. And now this is a really straightforward multiplication problem, and our answer is 48. So that's how we use the reciprocal to tackle those division problems. Okay, next in that chapter, now we were simplifying variable expressions involving quotients, right? And in this case, when it said to simplify, remember our goal was to have no fractions in our answer. We wanted our answer to have no fractions in it. So remember we said we're actually going to create some extra fractions before we get rid of them. So in this case, what we did was we said we're going to break this up into 2 fractions. And they have the same denominator of 4. And now because this is addition, I put a plus sign in between. My first term of the numerator goes over my first fraction, and my second term goes over my second fraction. And now we can divide the numerator by the denominator. So 8 divided by 4 is going to give me 2x. I have a plus, and 24 divided by 4 is going to give me 6. Now, we know from what we've been learning recently is that these are not like terms, since one has an x and one does not. So we can't go any farther than this step at this point. So that's where we would stop. So the only difference in these other examples is you're going to have to be careful because now we have some negative signs introduced. You're going to have to be careful when you write those answers. So that covers the material that was on our first quiz of the chapter, and now the rest is going to be information or material that's been much more recent. I'll still go through maybe one of each of these problems just so you have something to reference, but again, this should be much more fresh in your memory. So in section 2.6, we learned how to simplify expressions using the distributive property. And there's a couple of things that I'm thinking about when I'm reading these directions here. So simplifying, I'm thinking, okay, I need no parentheses in my answer. So I'll know it's simplified if my parentheses are gone. The other thing I'm thinking is when I see distributing or distributive, I'm thinking multiplication. Okay, and Mrs. Jennis has a nice note here to remember to multiply by both terms. So in my example, here's where making these arrows really will help you to remember to do that. So the first thing I'm going to do is 5 times x, which gives us 5x. And now I'm going to distribute to my second term as well. Doing 5 times 3 gives me a positive 15. Again, the process stays the same each time. You just have to be careful to take into account your negatives. Next up in section 2.7, I think, with simplifying expressions by combining like terms. Okay, so in this case, simplifying means no like terms in your answer. There should be no like terms left. Okay, and we know when we're combining like terms, the operation we're using is addition and subtraction. And here we're going to be really careful when we're boxing or highlighting or circling or underlining to make sure we're taking our signs with us. So I'm going to actually jump to number, let's see, what do I want to do here? Let's do number 9. And so when I'm looking at this, I know like terms, and maybe let's make a note here. Like terms, we know have the same variable raised to the same exponent. So if I'm looking at number 9, I notice that this term, negative 5y, has a y, and so does this term, negative y. So I have two like terms and then a loner term, which I know I'll account for in a minute. So now I'm going to be really careful here. When I'm combining, and I'm going to get my calculator, when I'm combining, what I'm actually putting into my calculator is negative 5 minus, and I know my coefficient here is a 1, so I'm doing negative 5 minus 1. I'm entering exactly what I see here, which is negative 5 minus 1. And that gives me a negative 6y, and then I'm going to bring down my positive 3. So we've seen, everyone seems pretty comfortable with this topic. Again, it's just a matter of keeping track of those negatives and making sure you're identifying your like terms correctly. So now the last piece of this was simplifying expressions by distributing and combining like terms. Right? We said we always multiply or distribute first so we can get rid of the parentheses, and then we combine our like terms. So I'll do two examples here. First one, I can see here that I'm going to distribute the 4 to the x, which is going to give me 4x. And then I'm going to distribute 4 to a negative 3, and 4 times a negative 3 will give me a negative 12. I don't distribute to the negative 7x because it's outside of the parentheses. So all I need to do is bring that down. So now I've distributed, my parentheses are gone, and I'm going to go ahead and I'm going to identify my like terms. Again, when I go to my calculator now, see if I can put this where you can see it, I'm going to type in 4 and then minus 7. And that's going to give me a negative 3, so I'm going to be careful to write negative 3x and then bring down the minus 12. I'll do one more because it's a little bit different. Let's look at 18. So now kind of my distributing is at the end, so I have to be careful what I distribute. And in this case, I'm actually distributing a negative 4. So a negative 4 times 3 is going to give me a negative 12x. Then I'm going to do a negative 4 times a negative 1. A negative times a negative is going to give me a positive 4. And now I just bring down the 13x. So I'm going to identify my like terms, find them. It's 13x minus 12x. So if I had 13 and I took away 12, I know I have 1x left. Again, if you write a 1 in front, that's okay. I just don't do that. But it means the same thing. And now I just bring down my plus 4, and that problem is complete. The only way this gets more challenging at least for our purposes, is these bottom problems where I actually have to distribute twice. The process is the same, I just need to distribute 2 times to get rid of all the parentheses before I combine my like terms. So hopefully this will be helpful to some of you, especially for some of the old material. So feel free to use this video as often as you need to go back and review. And don't forget to study for the test. Good luck!